boop, 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 boop. Thanks for watching. Woo! Yeah. So we're doing modeling trig functions with phase shift. What? With temperature and with time. That's crazy. So we're going to do it in problem 4 with you right now on our homework assignment, which is right here. And so we have the latest sunrise occurs at 9:10 a.m. on December 21st. The earliest occurs at 3:43. Where are we, Alaska? What the? In June? The sunrise at 3:43 a.m.? That's crazy. That's crazy. So what we have to do is we have to convert first our times into minutes, right? Convert our time into minutes. So 9:10 a.m. is the same as 9 hours and 10 minutes, right? So 9 hours and 10 minutes, we have to convert. So we have to convert it to hours. And so how we do that is by taking our 10 minutes and dividing by 60 minutes per hour. And so that's going to give us 0.16666 repeating 7. Awesome. So maybe we'll just say like, I don't know, 0.167 would be good. Then we bring our 9 in the front. So 9.167. So 9:10 a.m. is the same as 9.167 hours, right? And so that's going to be our maximum. That's the latest that our sunrise will occur. Yeah, this is probably the hardest part of the problem, is just converting these to hours, man. So then we're going to take 43 minutes out of 60 minutes to convert it to hours. And so we'll go ahead and do 43 divided by 60. And so that's going to be 0.71666 for repeating. We'll just say 0.717. Just round to the nearest thousandths place. 3 decimal places to be safe there. And so don't forget your 3, don't forget your 3. So it's going to be 3 hours and 717 of an hour. Cool. So that's going to be the minimum. So for us to write the equation of the graph, we need to go ahead and use the amplitude and midline formula. And so the amplitude formula, again, is the max minus the min divided by 2. So 9.167 minus 3.717 divided by 2. And that will be our amplitude. It will be our amplitude. So 9.167 minus 3.717 gives us 5.45, which I'm just double checking because I want to make sure I do this right. This is for whoa, I did some rounding on here. Did I do some rounding on here? What the? Let me see. So 9.167. What if we round that and then plus 3.72? I guess we could round 2 decimal places. Wow, is that going to be off by that much? That's crazy. So the amplitude, let's see here. Oh, I forgot to divide by 2. Forgot to divide by 2. There we go. Make sure we do this right on the video. So that's a bit closer. There we go. So that's going to be 2.725. So the amplitude is going to be 2.725 from the midline. That's 2.7 up, 2.7 down. Cool. So also for our equation, we need the midline. And so the midline is going to be the exact same thing, but add the maximum plus the minimum divided by 2. And so go back to our calculator. If you actually put a second enter brings the last thing you did. And then we could just change that to a plus symbol. Nice. And then divided by 2. You want to make sure to add them together, then divide by 2. Because if you do something, so 6.44, so that's right. But if you do something crazy like this, and then divide by 2 without the parentheses, you're going to get it wrong. 11.02 is wrong. So be careful there. It's a 6.442. So 6.442 is what we're getting there. Or 445. Either way, it's probably close enough for us. Okay, beautiful. Just depends on how much you round. Okay, beautiful. So then for the equation of the graph, we have the amplitude, we have the midline. Now we just need the period. Well, the period is going to be one full cycle, right? And since we're doing December 21st and June 21st, that means we're talking about days of the year. It's going to be talking about days of the year. And so that means that our period then, if it's going to be days of the year, will be out of 365 days. Okay, so we're ready for our equation. Here we go. So number goes amplitude, and then it goes cosine of the function, blankety blank, there we go. And then our midline. So our midline again is a plus 6. Let's see here. Oh, I guess it just depends on how much you round it. That's interesting. Let's see, 6.439 or 6.44? I don't know. Why am I getting two different numbers here? There we go. I mean, they're both pretty close. Yeah, 6.439 does round up to 6.44. We'll just round it there. I'm showing if you round it in a different way, you could also get 6.439. I don't know. Pretty close. Just both of them are about 6.44. Cool. And then the amplitude is 2.725. So we could write that in there. So 2.725 is our amplitude, which is 3 decimals or 2 decimals. It'd be 2.72, 2.73. Cool. So in Canvas, I will give a range. If you put, pretty close to that, then you'll get it right. You'll get it right. Okay, don't round too crazy though. Okay, beautiful. And last but not least is the period is 365. Now remember that the period 365 goes in the bottom, and it's the b value, right? This is actually the b value, and so the b value equals 2 pi over the period, which is over 365. So that means we need the 2 pi on top. Okay, there we go. Woo! Whoa, we're forgetting something new. Wow, what did I forget? What did I forget? There's something called a phase shift. Something called a phase shift that we're going to go ahead and teach you right now. And so these problems, we do have to phase shift a little bit there to get it to model correctly and match up with our data, right? And so I'm going to go ahead and scoot this down a little bit like this. There we go. Whoa, what the? Sorry. We'll erase that. Okay, so the phase shift, here we go. That's a fourth blank, you guys. That is a fourth blank. So we're going to go ahead and do another parentheses like this. And then now we're going to do the phase shift, which is x minus blank. And so that's called the phase shift with modeling word problems there. And so what we're going to do to phase shift that is it's either going to be December 21st, which is, if you think about it, December 31st is 365 days. So if we minus 10 days off, that would be 355 days, or you can Google it. And so December 21st is the 355th day of the year. Nice. So I tried using both of these. I tried using December 21st as my phase shift of 355, or I tried to do June 21st, which is the 122nd day of the year, but that didn't seem to work, and I'll go ahead and show that to you. Okay, because we're going to want to go and graph it next. So we are definitely want to use the 355, but let me go ahead and show you why, so you can see why we don't use the phase shift of 172. So for this, we'll just go ahead and let's go ahead and use decimals. Let me make sure I got decimals up and running. Is it working? Oh, it says recording. Okay, here we go. Okay, so we got decimals. There we go. So with decimals, we're going to carefully plug this in. So 2.725. Awesome. And then we'll go to functions, go to cosine. We are in radians automatically with decimals. The reason we need radians is because we're dealing with 2 pi. So 2 pi over 365, right? And then we'll do a right arrow, and we'll do another parentheses. And then we'll stick our phase shift in there. And so our phase shift is going to be x minus December 21st, which is 355. And then we'll go in close parenthesis, and then plus our 6.44, which is our midline shift. Nice. Okay, so this is a crazy window going on right now because we're really going to have to zoom out. And because we're going for a full 365 days of the year, right? So, whoa, we really got to zoom. Whoa, that's too far. Okay, so that's pretty good. So we're going to go ahead and zoom out there. Go ahead and zoom out. Awesome. I don't know how to make it so we can... I don't know. I think there's actually a way to do it. I don't know if you've seen this before. You can actually set your scales. And maybe my y-axis is like way too high. So if I want to see a nice curve there, I could maybe, I don't know. We're not going that far, are we? With our, I'm just going like 0 to 9, maybe 10. So for my y-axis, maybe I'll just go like 0 to 10. That'd be cool. Ooh, pretty! Nice, I like it. Okay, that's really curved. That's nice. So let's make sure. So the phase shift at 355, what it wants to do is it wants to go ahead and start us off 10 days back. So let me tell you what I mean. So let's say it's right here at 0, that's like December 31st or January 1st. And so if you go 365 days and minus 10 back, that would give you the 9.165 or 9.17, which is our time, right? Our 9.17, 9.67, that's the 9:10 a.m. So that's our maximum. So that's looking good. That's looking good. Then we want to go ahead halfway through the year. We want it to be at about 172, which it is about, almost mimicking our data. And also 3.715 is also very close to our y value, 3.72, which we got. Let's double check that right here. So yeah, 3.717 or 3.72. So beautiful. And then we'll finish over here. Back at the top of our 355, cool. And so, but really we're going from here, full cycle, from there to there. Cool. So there's the right graph that we're looking for. The reason why you don't want to phase shift with the other one, which is June 21st, which is the 172nd day, is because look what happens. So when you do that, then all of a sudden you're not really looking at, you're looking at what the January as the 3 a.m. No, it's during the summer. We're not talking December. Yeah, so that's not right? This is like backwards or upside down. So yeah, in June we're 172 at the 172nd day of the year. We're not at 9:10 a.m. So that's why this is wrong. So that's why we don't want to use June 21st, but we do want to use December 21st. So that's the 355. Cool, there we go. So there's our graph. So you can go ahead and sketch that graph there. Draw the graph approximately. Awesome. So we can go ahead and you want to draw that graph on your paper so you get used to drawing these things and doing them accurately. So again, right about here is where our December 31st is, right? Or December 21st. Yeah, so that's the 355th day of the year. And then we'll start in January again. There's January. So that's December. That's January. Good. And then we get all the way down to our minimum right about here, right? And so our minimum is at like 3.72-ish. And our maximum again is at 9.166 repeating, or 9.167. So we'll come down from December, January, down to the sunrise getting you up way early in the morning during summertime, lots of sunny hours during the summertime, because we're in Alaska, I guess. And then back up again, and then back up again. And so this will be June, which is the 100, this will actually be June 21st, which is the 172nd day of the year. Cool. And so, cool, there we go. Awesome, possum. And this will be back to December, and this will be back up top there at 355 or December 21st. So hopefully this is making sense. Definitely watch this video again. Okay, what is the sunrise time on February 21st? Well, let's see. How many days in January? First of all, so there's 31 days in January plus 21 days in February. So we're actually looking at the 52nd? Looking at the 52nd day, right? X equals 52nd. So here's January, here's February, so forth. So we're basically at 52, right? At x equals 52. This is x equals 172, 55. So at x equals 52, what is our y value, right? what is our sunrise? When does it rise at? Is it 8:30? When is it? And so what we can just do is we can go to decimals or our graphing calculator and type it all in. Or to make it even easier, you can go ahead on the 52nd, oh, that's x equals, so we're going to plug in for x. So we'll go to x, and we'll actually plug that in. So the 52nd day of the year minus our phase shift, so 7.75. So about 7, what is that? 775 is like, yeah, 7:45, duh. Okay, there we go. So our answer to, what is the sunrise time? Good. So what you're actually doing is you're taking your whole equation and plugging it in for x. So 2.725 cosine, 2.725 cosine, with our period of 365 days, times x, which in place of x, we'll put our 52nd day of the year, minus our phase shift, 355, woo! This is intense, plus 6.44. And so then when we do that, right, so we basically plug in right there with our equation, then we get y is equal to 7 point, what was it again, 7.75. So 7.75, or if you round that up to 7.8, that'll work. Anything between 7 and 8 should work on Canvas. Cool. And that's AM. If you want to convert that back to minutes, don't do it. Just leave it as that. Okay, beautiful. It could be, yeah, 7:45 in the morning. Okay, the sunrise time is earlier than 5 a.m. for how many days? So basically what you'd have to do is you have to plug in where it equals 5 for the y value, right? If you're in 1050, 1060, all the different ways that it plugs into the y value into that crazy equation and solve for x. Ooh, solve for x. So set, this is for if you're in like 1050, right? If you're in math 1050, you'd have to be crazy and be awesome actually, but crazy and awesome. So you get your college credit done in high school. Whoa, college algebra. And so what you do is you go ahead and set the equation equal to 5. But really, if you use your graphic software, that'd be a lot easier. And so we'd go ahead and change this back to x. And now you could actually just, where is it below 5 a.m.? Where's the sunrise below 5? So if you just do y equals 5, it's going to do a line straight across so you can intersect. And you can do that on the graphing calculator. So with the graphing calculator, you'd have to use second calc and then option 5, an intersection. You have to do that twice. Intersection. Cool. And so to be able to find it again, we're going to take these two numbers and minus them from each other. And so we're going to take 231.407. 231.407. What were they again? 231.407 minus 113.593. 113.593. We get it. We got it. Woo! So 117.814. That's going a bit high because we want below 5 a.m. We're right at 5 a.m. So you'd actually want to go a little bit lower than that. So I would actually probably round down to 117.7 or even 117 is my right answer. And let's see here. So we go back here. And so basically all we did was we used a graph. And at y equals 5, we kind of did a straight line there. And then our curve came down like that. And so those were our two places that we did. And so we did approximately, what was it again? So we did approximately 231 and 113. So 231, approximately 113, good. And we went in and found the difference of those. So 231 minus 113-ish. I know there's some decimals there. So that's going to be 11 minus 3 is 8. 2 minus 1 is 1. 1. So if you put 18, you'll get it right, but we want to be below 5 a.m. So that's probably going too high because that's right at 5 a.m. So if we want below 5 a.m., I'd probably go down a little to 117.7 or 117 would work. Either of those would be good. Woo! All right, thanks for watching. You behind the screen. Thanks for watching. Tough problem, but we did it together. And thanks for watching. Have yourself a good day. Oh, do 5 now. Do 6. You got this. You got this. Ace that test. Here we go. Here we go. Thanks for watching. Quack. Quack, quack.